Hey guys, today I'll be showing you guys traversal. So this is what's important for your DFS based solutions, and the idea is usually to traverse a part of the tree, so the left or the right, and we do it on an order. And there's three types of orders: so pre-order, in order, and post order. There's also another Euler tool. I'll just write it down. Euler tool traversal that you can check out. But this one is going to be about your these three traversals only. Now for pre-order, I just want you to remember this abbreviation. So NLR. So that's your node, that's your left, and that's your right. And all of these three orders just come down to the same thing. NLR is for pre, and if you just shift L and N, then you get the in, and if you just shift N to the N, then you end up with the post order traversal, and that's it pretty much. Now I'll show you an example on this tree over here, how we do pre-order traversal on it. So pre-order traversal, and like I said, NLR. So we process our node, the one we are at first, then we go to the left child, and then we go to the left child of the left child, left child of the left child. We see the right. If no right, then we come back, then we process the right child over here, then we come back, then we process the right child over here, go to the left, then go to the right, and we're done. Now to write it out, I'll show it to you a bit more simply. Okay, so first node, so we start off at the root always. We always start off at the root, and since we do the processing on the node as soon as we visit it in the pre-order traversal, we'll add one to our array. So this is like the traversal array, you could say. Then we do one, then we go to the left child, NLR. We go to the left child, and as soon as we go to the left child, it becomes the node that we are at, like this. Okay, and once you're at it, like I said, we process the node we visit as soon as we do it. So we'll also add 2. Then we'll go to the left one again, and now you can envision the same thing, NLR, except this time there's nothing for the R. And we'll do it again, so 4. Then shift it one more down, this becomes N, and there's no LR, so now we just cite 8. Then we go back, because we haven't calculated this one's R, right? So now we'll go back and we'll do 5. Then we go back and we'll do ones right now. So we'll go 3, then we'll go 6, and then 7. Because as soon as we hit 3, you can imagine LR again. That's it for pre-order, pretty simple. In this one, just remember, we print out the node as soon as we're done, like as soon as we visit it. And for in-order traversal, it is L and R. So we'll process our left node first, and then our current node, and then the right node. So to show it to you guys, if we go to, so we start off at the root again. Now you can see N, L, R. In this one, we don't process 1. We go to 2 straight up. Then we go, okay, now this is N, this is L, this is R. Now we'll hold that R. We'll come to left first. Then this becomes N. We'll go to left. Right is nothing, so no right. And we'll immediately say, okay. Yep, we'll go 8. So the leftmost node. Then we'll go back and we'll process the node that we were at, 4, our parent. Then we were just at 4, so we'll go to the parent, 2, we'll go to the right, we'll go to the parent of 2, and we'll go to 3. No, we don't do 3, we go 3 and then we go left of 3, so 6, then we go back to 3 the parent, and then we go 7, and that's it. Now post order traversal, bring n to the n now, so LRN will traverse every node except for the node that we were originally starting at. So if I write it down all over again, why doesn't it erase on the first try? There you go. If we start off at the root, now we can draw n, r. We'll go left, we go left of the left, left of the left, then we go right, and then we process n, right? That's literally it. So we hit it same way again. 8, we'll see 4, and then we're at the left now, so we'll go right first, so we'll go to 5, then we'll go to 2, then you see we go to right, so we won't check 1 right now, we'll go to 3, we'll go to left of 3, then right of 3, so we'll hit 6, 7, then 3, and then 1, and we're done. So it's literally just changing the place that you process the node, and that's super simple. If you just, and the way to do it in trees is you usually send like a recursion. So if we have a node, so if we consider pre-order, we can say print the node that we are at currently, then send the same function on the nodes left, then send the same function on nodes right. And just to show you, it's literally the same for n. If we just do func on the node left, now when I say func, it's the same function that you've used on your original node, so it's like a recursive solution, right? Then we have a print node, and then func node right, and like I said, for post order it's literally just left, right, node. So if you just change the print statement to here, then it works. Now there's 3 lead code questions, so you can do the traversals yourself. I would recommend you check it out, do it. It's pretty simple, it's the same exact thing. Now what needs to, like the key takeaway from this is just the traversal, remember the abbreviation, and that's it pretty much. It'll come in more handy later once you start doing tree questions, but for now just remember the abbreviation, see how to process the node, see how the traversal actually works on the tree, and do these questions on lead code, the pre-order, in order, and the post order.